Sounds good. Welcome, everyone. This is episode 2 of the Passive House Accelerator Construction Tech. So thanks, everybody, for joining us. And today we have a guest, Darryl Caunt, who will talk about this exterior insulated build. So lots to look forward to. I want to do just a quick introduction to who the Accelerator is and what Construction Tech Tuesday is about. So the Passive House Accelerator, we're a collaborative online platform for sharing innovation and thought leadership in passive house design and construction. And we publish articles and interviews. We produce weekly confabs like tonight's and tomorrow's happy hour, and that feature passive house pioneers from around the world. And we're working to elevate the work and programming of the passive house movement's leaders, practitioners, and organizations through interviews, articles, social media campaigns, videos, podcasts, you name it. So our aim is to catalyze zero carbon building by accelerating the adoption of passive house building. And Construction Tech Tuesdays, we've launched with our co-hosts, Sean St. Amour, Kevin Brennan, and Mark Willie. And the purpose here is to share the technical, the technique, and the technology of passive house construction tech. So each week we'll welcome guest practitioners to dive into the details of practice with the builder and tradesperson as our target audience. So we welcome folks from all corners of the construction and design world to join us each week. And here are our handsome co-hosts, Kevin Brennan, Sean St. Amour, and Mark Willie. And with that, I'll let them take it away.
Hey guys, welcome to Construction Tech Tuesday, round 2. We have quite the show in store. We'll be talking about the step code projects out on the West Coast in Vancouver and British Columbia out there. It's a nice time of year here in New York City. We're excited for the holiday to be coming around and hope everyone is having a good go at it.
Okay, Kevin, I'm still reeling over last week. It was a brilliant episode. So tonight, we're glad to have everyone back. And episode 2 is exciting. We want to encourage you to ask questions. And so the chat is open for that. It's also open for you to be you. So if you have your side discussions or your insights or your critiques, be yourself. When we share, we learn your perspective and we also enhance our own. So those questions that are puzzling you need to be shared with the rest of us because maybe we don't have the perspective you have. So please put those in. At the end of the show, you have the option of saving all these chats. And so not only do you get to see that you asked a question, but that a colleague in the industry has asked a question, and hopefully you get the answer. If you don't, give us a poke. We will make sure you get that answer. Even if we don't have it, but Kevin Brennan's on the show, so we will have the answer. No sweat. I'm thrilled with tonight, and I would like to pass the royal baton to Sean St. Amour.
Thanks, everyone. Great to have you. Let's dive into things. Last week, when we started the show, we talked about the 5 passive house principles. As we kick things off tonight, I want to dive into the order of importance of ensuring that our walls assemblies are built with the right kind of level and details they need to have. So I'm going to share my slide. We talk about how our assemblies need to deal. We need to make sure we've kept care of the water, the air, the vapor, thermal in that exact level. And so we're going to showcase this lovely project by Darryl. And here's the backyards. You got to see the front and the back. But when we look about water, right? So we want to ensure that if water hits the walls, the windows, it's got a way to shed properly. We're going to talk about some shingle laps in a bit. We're going to talk about the air barrier. Again, in this amazing wall system where with exterior insulated, how it's going to be able to tie in. And of course, make understanding where the vapor needs, which way it's going to be driving depending on what climate you're in. And so in this particular case, they've actually got a vapor retarder. So they've eliminated poly, and the plywood is going to be the vapor retarder in this project. And then afterwards, again, comes down to how much your sweater is going to be installed. And in this case, you've got some structural insulation below the windows, some higher insulation level material around the sides and the top, and again, rock wool that is going to be the sweater and the detail. So make sure you understand those order of importance and Zach's going to play the video. Actually, sorry, 1 second, so you can get one more slide here. You can see the exterior insulation that's added on. Lucky that Darryl had a building envelope consultant, Hamid Hedrulia, who was involved, and I think Darryl's going to give him praise. I'll definitely give him praise. And why don't we kick off this video, and you'll see Darryl and Hamid.
On a job in Kamloops, going to meet with Darryl from Tri-AMM Developments and his team in a bit here, but I just want to go over all these amazing details of high performance. So really elaborate design, and want to go through some of the uniqueness of this whole system. So you can see the detail of the air barrier, a piece of wood to help out because it's glued. So if they ever had to repair that, the styrofoam is glued to the wood and all bolted through, connected. See the detail of the roof. Let's just review this detail here. So again, we've got the compact foam that actually is in behind here. It's actually got more support, so we can zoom underneath here. So you can see the compact foam. You can see the detail of how they're making sure that the water stays away. Airtight connection coming through. This will have the rock wool already, the rock wool will be the insulation that ties this, and so that the cladding will come right up to here and have a window sill. So you can see the brand. So that block is installed, as well as this block here, so that the furring strips will then hold the rock wool in place. And again, those are thermally insulated. So you got a 2x6 with the foam, and the furring strips will ensure that the rock wool is in place and that the wall is nice and straight. Of course, some of these penetrations will have a EPDM gasket to ensure they're airtight. At air barrier continuity, we've got the garage coming out. So actually we've got the WRB for the garage connecting to the WRB, and air barrier for the garage comes in behind the foam, now goes to a membrane. It's taped into the wood, but the window is going to sit right here. So a little further out than maybe we want in high performance, but that's what the design dictates. So you have air barrier in the windowsill in place, and the structural support to hold this full window. And so you can see that connection all the way through. And then here you have a different product, compact foam, that again will support that upper window. Really skookum detail all the way up.
We've just finished the air barrier, and so we're now going to go to the weather barrier installation.
Yeah.
So you have it going up.
So the air barrier goes behind that insulation around the window, yes? Yes, that is already done. And now you're doing the here, okay, and then it comes here. Perfect. And you just want to make sure you go right and tight at the corner.
Very tight to the corners.
Yes.
So working it through, working it around. Making sure that it's very tight to the inside. We do have a stapler
That's not part of our air barrier right now. This is just the protection for the rain. Perfect. Well done. Make sure it's stretched a little at the top so that when they tape, yes, maybe, yeah. There we go. Okay, Darryl?
Yes, looks good.
Example of this window getting done, you've got the air barrier coming through, connected. They've got the foam installed. They'll put in the compact foam here. And you can see now they'll cut this back. This is just protection board for all the roofing details and how they were able to connect it, make it look so nice. Then they will put in the membrane underneath here and then have it lapped over there. But they'll use caulking to make sure this air barrier is continued all the way through. Very nice detail. Amazing design. And then here's that entry again. And all those funky details. In the roof. Oh, it's air barriers below, ventilator angle of this beautiful view here in Kamloops. So again, this whole deck here is insulated. It's above the air barrier. The air barrier is returning to the curb, and this curb already has that structural foam already installed. And so you can see how it's all weatherproofed, nice drainage, good flow, but all of this has been insulated above the air barrier. And you can see here the compact foam is already installed. They've already done a great job of weatherproofing, but you can see the details of the air barrier coming back to here. Exoseal with nice corners, insulation where the window will tie into. Really complex job here. Just amazing work of making sure that the whole roof can slope and drain, keeping away the water and not having any thermal bridges, or really minimizing the whole detail. So if we zoom in here, the window is going to sit here. This is the structural foam, again supporting the load that needs to come back into here. Air barriers continued. You can see the membrane tied back in. The level of detail of them taping it. They put in this strip of wood. And so then all of this is now tied into here. And then this whole cavity now gets spray foam because the plywood is air barrier to there. And that peel and stick, that white peel and stick, is the air barrier. And then of course, just for water maintenance, they've then taped it to the outside here. So then that gap in here is venting that upper deck. Similar to down here, you've got this vent that deals with all the cross ventilation to get rid of the air in that space. Same thing that's happening up there. Really amazing detail to allow the homeowner to have this, really fancy design.
Hey Darryl, how are you?
Good, how are you?
I'm very well. So it sounds like, so here we have a roof, lower roof, a wall, and another roof at the top. Would you please explain to us how you achieve the air barrier continuity? But first of all, explain us about the assembly. Is the roof exterior insulated assembly?
It is. And so we have the roof, exterior insulated roof
Yes.
that we're standing on.
Yes.
We have a vertical wall, outside insulation.
Oh, that is also exterior insulated
Exterior
wall.
insulation.
Perfect.
And then we also have the upper roof.
The upper roof is also exterior insulated. Perfect.
So that's our assembly.
So what is your air barrier on the lower roof? Can you? Oh, okay.
Lift up here. I'll explain. So here we have the peel and stick,
Okay.
and this is our roof air barrier.
And which goes under your roof insulation,
Yes,
yes?
it goes right
Okay.
up underneath the
Under
roof
the
insulation.
roof insulation coming up.
And then the continuation.
Can I ask a question, Darryl? What did you do so when the torch on guys, when they came and do the torching, what did you do? What measure you use so that they don't burn that air barrier?
So we had a protection board that came
Got
up,
it. Okay.
up higher. And so once the granular cap sheet was put on, we cut off that. So we protected and so it didn't melt the peel and stick.
Perfect.
So
Now that we did it that way, okay, so then now I see the air barrier of the roof, that peel and stick one. Can you show it with your hand one more time? Yes.
Here.
And how did you connect that to the air barrier of the wall?
Well, we have a double-sided tape. Maybe you can see
Oh,
it a
I
little
can
bit
see
here.
that. Let me just zoom in. Can you show? Oh, yeah. Okay, got it. So that's double-sided tape.
Double-sided tape.
Yes.
So it goes to the back side of the wall membrane.
Yes.
And so that's a continuation of the roof air barrier
Yes.
to the wall air
Perfect.
barrier.
And what is that tape? So can you put that down? So now you have a What is
So we
that
have a
tape?
positive left.
Oh, that tape is to seal the air barrier sheets.
Seal the air barrier for the two joints to the joint of the
Overlaps
wall
of the
membrane.
wall. Perfect. And then it comes up, and then what's happening here?
So this is continuation, and it's the seal to the top of the wall plates.
Top plate. So you
The top
basically
plates.
brought the membrane, you seal it to the top plate. I can see you also extended, in addition to the top plate, you also extended it onto the TGI blocking. Why is that?
Oh, that's the continuation, because we're going to have spray foam on the
Okay,
outside, and the continuation is the spray foam goes over top of the tape
got it.
and goes to the underside of the roof deck.
Understand? Yeah, okay, got it. Because you had a gap here, so if you would have stopped the tape there and then the spray foam come here, there was no continuity. So you extend it there, the spray foam come, and then the spray foam goes to there, and then from there,
Goes to the roof, which has a peel and stick, which has a roof membrane up there.
Got
And that's
it.
the continuity from upper roof to lower roof air barrier system.
very good. And what happened at the window? Do you continue that air barrier behind it? Oh, that's okay. So can you explain what you've done? Okay, so you extend the air barrier of the wall behind these guys?
Yes, the air
Okay.
barrier goes behind and
And
the
can you
build-up.
show me inside? And where does it end up when it goes in?
So it comes
Okay.
inside.
Yes.
So the air barrier comes to the inside, which
And
is
the
taped.
taped. Okay, so
And
you
it's
install your air
all
barrier.
four sides.
All four sides. Okay, so you install your air barrier first, and then you're installing this guy.
The exterior build out.
Why did
For
you
fly
decide
fires.
to do this instead of wrapping this membrane around?
So we looked at different methods, but the weather barrier now is going to go from the inside,
Yes.
and it's going to wrap around and come in and get taped.
Got
So
it.
that's our weather barrier that comes to here.
Got it. So I
And
understood
around
that instead of wrapping the air barrier around, which apparently was a lot of in and out, and it would have made the air barrier a little challenging, correct?
Yes, that's
Because you
correct.
go with here, air out there.
That's correct.
You decided to just continue the air barrier first and then build this over. Now you're gonna add additional membrane, but this one is a weather barrier,
This is
correct?
the weather barrier.
So it goes where? It goes from the
So it's going to come on to
Yes.
the air barrier.
Yes.
And connect. It's going to come out our window,
Yes.
a 5-inch window. build
Yes,
out,
yes.
And come in
and then
and
take
be
it.
sealed at the air barrier
Yes,
location.
yes, but a little bit out from the air barrier location.
That's correct.
And then the window air barrier is going to be connected to that one, correct?
That's correct. So once
Perfect.
the window is installed, the tapes on the inside.
The
of the window
tapes
will connect.
around the window, it will be connected to the
So
air
that's
barrier.
protecting up the air.
Perfect. Well done. So well done, Darryl. You're spending a very good time doing things right. Thank you very much for explaining that. So we look at the complexity of this job here. That's a bedroom underneath an exterior deck. And then you've got the living space. So you can see a lot of structural connections there. And then the windows and sliding doors come down right on top of that concrete. So let's go check out, this detail here and see what they've got going on. So let's look at all the details. We got insulation connects into insulation that then connects into structural foam. So the window now is going to sit along here. And so you get an idea of how they were able to make sure it's wrapped around all the way through and continues. Let's highlight this connection where we have, you can see it right in there. That's an armor therm, so that's a fiberglass piece that's in between the interior steel to the exterior steel, so it's thermally broken. And then you get over here, even a crazy detail where they've put blocks, and so insulation will go on there. So just a fancy detail to take care of all of these loads. The detail, and again, because of sequencing, they've already run the electrical, but you can see how the electrical box is then connected to some 2x6s. The exterior sweater that Rockwool has been installed. They now have some structural foam above that, used with a windowsill tape to make sure that it's water can't get into there, and how it's nicely tied in. And so you can just see the air barrier, all the details. And then we look into here now, is they've put foam above 2x6s. That's structural foam on the outside and a 2x6. And so the rock will stay in that area, but the furring strips will then connect all the way over to make sure the wall is nice and straight. Let's go over the level of detail here. You got the air barrier coming in. It's taped, nicely clamped with a piece of wood that's not going to go anywhere. Around the eye joist, they've taped it, but also put in some silicone. This will get spray foamed, so then the plywood up there continues the air barrier.
But again, just the level of detail on this project is just phenomenal. Even the gutter detail.
All right, thanks everyone. Hopefully you enjoy that trip up to Kamloops and to check out all of Darryl's work. And before I give him a huge praise, let's just give Darryl an intro. So Darryl's been a builder in Kamloops for over 30 years, hundreds of $1 million in his pocketbook from all these crazy projects. Being able to dive into a lot of the construction levels of skill, so scheduling, quality control, and budgeting, and has taken on this crazy task. So Darryl, why don't you come on and say hello, and we'll give you a huge nice golf clap. And if those are having a beverage, cheers to you and your crazy work ethic here, man. This is phenomenal.
Right. Well, thanks very much, Sean. Thanks for having me on, everyone. It's been quite a ride. I started as a journeyman carpenter, and at the very beginning, 20, almost 30 years, I suppose now. And our love of doing multifamily and commercial, and we've done many different projects, and I've always leaned to the single family and the high end and the camaraderie and the clients. And so I've taken that to another level now, and so fast track that to today. In this project, we had an opportunity to do this project as a high-end custom home. That's typically what we do. $300 to $1,000 a square foot custom homes. They take anywhere from 12 months to 18 months, that kind of scope of project, complex. But then this is a whole nother level in taking the high performance path. And so really enjoying it. And so I'm trying to give a little fast track intro here, what we do. So I only have a crew of about 5 guys. In this process, it's been a little bit tough in finding the right people because the patience and the OCD and what's required for this kind of level of building. So, and with the skilled labor shortage that we all know about, it's been very challenging. But we got a good crew now, and we're hitting a good stride. So
Your work speaks for itself, Darryl, and it was great to see you on site with your tool belt on, showing those demonstrations. I mean, that's true leadership, getting out there, putting on the multiple layers, putting your tool belt on, and be like, guys, this is how it's done. So we applaud that, and great work. Your details were phenomenal. The cuts on that foam, I was extremely impressed by. They were clean, they were neat. They were done with obviously skills and craftsmanship.
Excellent. Yeah, thanks for that.
Kevin, do you want to just dive into again the window detail with the foam and window placement?
So I teach the Passive House Tradesperson course here in New York City, and the biggest change agent I see in the course is when we ask the students to put the window in the insulation layer. So they all say, well, how do you do that? And then can the window float outside in the layer if the building is exterior insulated? I mean, you guys had your entire insulation system outbound of your structural layer. And that's why you put in all that compact foam and the window bucks and everything like that, right?
That's correct. Yeah, that's right, Kevin.
So when we teach the class, we go through an exercise where we show how you can purchase a high performance triple pane thermally broken window that's around R7, R8, and you take that same window and you stick it in the conventional way in the structural layer, and don't wrap it with insulation or is in line with the insulation layer, and very easily you take that high performance window, and because of the psi value of the thermal bridge around the window, or the psi value of the window install, the whole R value of the window installed goes down to around R4. So you're purchasing an R7 window, but the real results on the install detail is R4. So you guys did an amazing job of figuring out, as a design builders, of where to put the window and how to put it and how to handle the structural loads. And, you guys did a great job. So.
Excellent. Yeah. Appreciate that. Being the first one, we don't really know the difference. And so there's huge compliments I give to our building envelope engineer, Hamid. And so it's been a real step-by-step process. A lot of building envelope consultants provide you with details, and they say, okay, well, this is in this situation, this is what we do. And that's very typical in this industry, of course. Whereas this one, it's kind of like a design build from the beginning. we were provided this project by the client just as a draftsman. There was architectural drawings of 10 pages, no details. And so it's been quite a learning curve, and it's been great, but I have huge respect, and I just, there's no way I could have done this project without a building consultant of this nature, of being so hands-on. We speak, every day, FaceTime, about all these details. Today, for instance, there, as you saw in the photo, there's an outdoor kitchen on the main floor deck outside. So of course, the climate up here, it's cold, but we have hot and water, cold lines, drain lines. We have barbecue with gas lines. So penetrating the air barrier, but still thermally broken and still following in every detail that we do. It goes back and we double check the 4 building envelope control layers every time that we hit them. And so it's been in quite a process. And so we're in a good stride now. We're almost through the details, and the windows actually go in next week. So that's where we are in the project. So it's going good.
Yeah, it looks like you guys are ready to install windows, and that one picture during the video you showed, it looks like you have a mock-up window installed, and or a frame.
Yeah, so we're again with the client trying to explain to the client the benefits, and so because of the exterior insulation, so of course it adds 5 to 6 inches on the outside, plus the rain screen and your cladding. So with that, for us, that created a 7 3/4 inch drywall return on the inside for finishing. So my client goes, well, that's too big, but it's an education. You got to explain the benefits and why that is. And so it's been a learning curve for our client in that regard, but now they're on board and they understand obviously the big benefits for this.
Function over formalities.
Yes.
I always say, and then that windowsill now has, you can put a plant on it. You can rest something there as opposed to being a 2 or 3 inch sill with so it's great to see the work that you guys are doing. One clarification, question, being that I know the answer, I'm just going to ask it. Your goals on the project for air tightness is what?
Our goal is one air change.
One air change per hour at 50 Pascal.
50 pascals, yes. I came into this project, and being the first one, had a great building envelope consultant. It's not that if we go to a level 4, step code 4, I'm happy with it. If we get to 5, that's fantastic too. I'm not trying to, for this project, knock it out of the park and get the highest of everything. It's more for me is to gather as much information and consume everything and make sure everything's correct. And then on the second one, in between the first and second, we can take a breath and then talk to a new client and building envelope or architect and say, really sit down and, because obviously there's a lot of lessons learned, especially in the design stage up front. I can't tell you how much more time that this project should have taken, probably another 4 to 5 months of design and building envelope details and structural steel. There was opportunity to change a lot more things that would have satisfied the client a lot more. They're giving up things that he didn't know about, and things come up and go, I didn't know that was going to be so bulky. I didn't know, and we could have done all that for them up front. So I think the whole design build process, I'm going to take to the next level with a client. And typically we always just take draftsmen. Like up in BC, we don't need an architect to build a Part 9 custom single family home. As long as we build, it's about 600 square meters, I believe is the, and stay under that as a footprint, that falls into the Part 9 small building. After that, it goes to Part 3 into the commercial. So that's when, you have the light, fire, life, and safety components added to the house.
You guys have your hands full with design build wise. I mean, when we work on passive house projects with Mike and his team, like they're figuring out everything up front. It's so much easier to change something when it's a pencil mark or an AutoCAD and to change something rather than being on site with materials and waiting there. So you guys took on a project and you reinvented it and took it to the high performance level. And that's a big feat. And from looking at your details and the work that you're doing, I don't think your next project is going to be step code 5. I think it's going to be more like passive house plus, because you've got the hard stuff figured out. And take that great team photo of the guys on your team that you've led and taught of the final blow door test, and you know, they'll have their thumbs up in the air and cheersing, and it's quite the accomplishment to see the guys that have been doing it for 15, 20 years to get really, really excited about that final blow door test.
Yeah.
I've been on projects where the last person in the world I thought would be excited about it was like the electrician, you know, and you know, he's in the photo. He's like, "Yeah, we did it." And it's like, "Yeah, you did a little bit of it. I did most of it." But
I could tell you that there's actually a momentum that's different that I'm used to on past projects with our trades and suppliers. Again, Hamid really promotes that on site and be able to teach and explain, like the electrician a couple of weeks back, and how we're going to go through the air barrier. We're using MatchVest for this project, and how we're using the tape to be able to pinch the wire in a way that creates the seal, and how we're going to, you know, penetrate a lot of these subtrades, like EPDM gaskets, all the different things, and it's the trades are learning, and so they understand that we're going to be doing it, the air testing and stuff, and so it's been good, and everybody's really on board. So it's a really cool, positive momentum that I haven't experienced before.
One thing to point out is your work speaks for itself, that you're a true craftsman. And I see guitars in your background, so it sounds like you're an artist.
Yeah.
And your work is in Passive House is what I say is it's a little bit of arts and crafts, and it takes the pride of somebody doing the work to get it to that level. But it's a little bit of art, a little bit of science and craft, and creativity definitely comes into play, and you can see it in your work. So
yeah, appreciate that, Kevin. Appreciate it.
I would expand on that, Kevin. So Darryl, the sequencing that I saw in the photograph to me shouts technique. So when you carried the air barrier around the window and then you added the structural foam glass and later on the WRB, it's just a perfect sequencing and great technique. You mentioned there was 5 guys on staff or crew total.
Yeah.
So for the audience, are those 5 folks, are those the same ones that frame, sheathe, air barrier, install windows, and do cladding? Are those the same 5 guys?
Yes, they are.
Okay, that's a benefit. And the fact that you pull it all together, your 1 ACH to me looks like you're going to hit that with your technique. And I say those penetrations for the outdoor cooking area are probably the most combined square inches you have. Everything else seems, as they say, dead nuts.
Yeah. Thank you, Mark.
Well, excellent, Darryl. We've got some questions for you, so let's go to the audience. There's a bit of a queue. So, German, you had one of the first questions talking about the plywood. I can't remember if we answered it or not, but well, yeah, come on.
Hello, great. Hi, everyone. So I wonder what's the thickness that you guys use for the air control layer? I'm sorry, the vapor control layer, because somebody mentioned on the video that you use the plywood as the vapor control layer.
Yes. So it is 1/2 inch German. So it's 1/2 inch plywood, and it does have the gaps so the plywood is acting as a vapor retarder. And it does have the gaps because of structural, you never put plywood tight together. So with advice and discussion with our envelope consultant, you know, he says, you know, it's okay because they're 1/4 inch. They're not like the 3/8 like you sometimes guys use when you use OSB. It's got to be bigger in those projects. But obviously these projects, we never use OSB. But so with a 1/4 inch gap, you could seal that. I build an envelope for this project. His advice is you could seal it if you like to, but as a vapor retarder, it's not required.
So just to point out, you guys are in seismic. You have seismic requirements on the west coast of Canada there. So
yeah, in Vancouver it is, but not in our area. It's in Kamloops. It's not a seismic requirement, so we don't have the hold downs and etc. that Vancouver does.
But that requirement for sheathing to be gapped is carrying over into your jurisdiction, obviously.
Yeah, and it's also it's a common thing we do for settlement as well, for compression of the building for the weight, and I suppose one of the advantages, especially for exterior insulated buildings, it's not a huge one, but it is a benefit, is sometimes when you have a stucco layer, a 3/4 inch cementitious stucco on the outside of the building and there's no insulation, and it's just paper and wire on the exterior plywood. The building does, especially if it's a large home and it's got, we got big snow loads here, and so there is compression. So stucco can crack. And when the plywood is too tight together, it's not anything to do with seismic, but it's about compression, because the plates will still compress, and so you'll get stucco cracks. And that's the reason we do it here, is to leave that 1/4 inch gap.
Cool. So one of the things to point out in German's question is that you guys are using the plywood as the vapor control layer, but your air barrier is the MyJust from Sega, right?
That's correct, on the warm side of the insulation on the plywood, yes.
And the outbound wise, the exterior insulation is going to be rock wool, 6 inches of rock wool, I believe, or
It's going to
mineral
be
fiber.
5 inches of comfort board 110 Roxol.
Oh, 110, nice. Look
Yeah,
at
we
you.
played with the 80 and then the cavity rock. I'm very concerned and with the compression of the Roxol. So we're going to be using 2x4s as the rain screen for the vertical attachments through the 5 inch, using some structural screws, like 6 and 8 inch screws. That's been approved by the engineer.
Mm-hmm.
And so that's going to work there. So there was too much compression in the 80, and obviously the cavity rock is very, very fluffy, so it wasn't even a consideration. That's something you'd put in a cavity wall instead, or a ceiling. But as far as exterior insulation, 80 would work for some. We have a very particular client, and so those walls have to be very, very straight. So anything that we can do to be able to make sure and ensure the straightest wall possible, that's what we're going to do. So one of the reasons for the 110.
It's a very modern looking building, and if those walls don't look straight, it could cause an issue. Just to be technical and to point out that the ratings on the rock wool is the cavity rock is 40, or also known as 40 from 35. That's a 4-pound density, and then the 80 is an 8-pound density, and I do believe the 110 is an 11-pound density. So that's the density of the product that
That's
goes.
correct. Yep.
So one of the benefits that when we started this project with our building envelope, it was the decision of where to put the insulation, because we originally started with 4 inches of 110 on the outside and then 1.5 inches of 80 on the inside. And then we'd use in some costs and the labor to cut all those, because rock wool, they don't sell the widths proper to cut between 14.5 inch for 16-inch studs on the inside. So the complexity and amount of work. So we just said, you know what? Let's put everything outside. And so we use a 2x6 as a cavity wall on the inside. So that's what we committed to. And that way we have all the penetrations. And so there's no vapor barrier. So can you imagine, and I know everybody can, how many penetrations there will be on the exterior wall and the ceilings where there's vapor barrier when you do have a bat in an interior filled wall. So you've got the speakers, you got electrical boxes, gas lines, pot lights, all kinds of stuff. So we've eliminated all that. There's no vapor boots required for the ceilings. Our roof is about, I don't know, 2,500 square feet at the very top, square footage at the very top. We only have 5 penetrations. 2 is a bath fan, 3 is the sewer vents, and 1 for radon gas exiting. And everything else is sidewall, and everything else is underneath, so nothing needs a vapor boot. So that's one of the huge things for that, why we wanted to build in this way.
Great. One thing I'd like to let's kick it off to another question, Sean. What do you got?
I don't know the name here. It's WD Prince Inc. Had a question.
Darryl, fascinating project. Really appreciate the presentation. Your blower door test. When do you plan to do your first blower door test?
Just before we do insulation. I guess it doesn't matter because the insulation's on the outside, but we got to get, so the windows are going in this next week, and then we have the trade rough-ins to complete. And then we're ready for a blower door testing. So being that it's my first time doing this, and right from start to finish, so I don't really understand and fully yet. I get an understand a little bit about how that blower door test works. One's with masking and one's without for our mechanical equipment, but you know, I'm relying on our energy advisor that's going to do the blower door testing, and Hamid, our building envelope consultant. So you guys are more more experienced at the blower door testing. So that's, I do believe we're going to take a test at that stage and then another one at the end of the project.
Thanks. Brian Keek, you had Sir Keesh, you had a question.
Yeah, my question is about the what type of windows are being used, what manufacturer, and how they're being fastened to the wall assembly. I saw that it was obvious they're flashed really well, and how they're getting rid of rainwater is really well detailed. I just wanted to ask how the windows are being fastened to the building structure, the wall structure.
Okay, so the windows are from Austria. They're triple pane. I don't know the exact R value, but it's a U value of 0.6. The windows are about 3 1/4. The jamb is 3 1/4 inches wide. The glass with the triple pane itself, so the two air layers and the triple pane is 2 inches from inside glass to outside glass, and that is going to be in alignment with the insulation, of course. So going to your question, we're using a Josco windows out of Austria. To install them, we're going to be using the, if I pronounce it right, the gasket that goes around the window first before it goes into the rough opening, Ilsbrook, I believe it is, expanding foam tape. And that'll go into the rough opening. They have metal tabs that get screwed to the frames on the sides, and it's fastened in with screws into the 2x6 wood framing to hold the window in place. Outside, it will be flashed for the waterproofing. So I think that, yeah, and so we still have to go through that part.
So there's that window and how you're gonna put it into
Yeah, so there'll be a flashing in that corner, and then obviously all the way around. So we still have to put 1.5 inch rain screen and 1/2 inch plywood over top of that exoseal still. So, and then it's the cladding. So we're gonna have probably a 3 inch deep exterior flashing that's sloped, right? So the sides, header, and top. We have a budget for flashing for this project because it's got to be done really correctly. So, and not only correctly for the weather and the water penetration protection, but aesthetically too, because as you all know, it's really tough to do really well done flashings, have them braked and bent properly and installed properly.
So if I heard you correctly, you're going to use an expanding foam around the window first, and that's going to be your watertight seal on the outside. And then are you taping on the inside, or that's your main seal?
Yes, we are. So we're using, I know you can get tapes that'll do both the thermal as well as the air barrier, but we're going to use two. And so we're going to use the Ilsbrook for the thermal side. So that's going to go around the window frame. And then on the inside, we're also going to seal for the air barrier to the framing where the tapes are for the air barrier, and then to the window frame itself. Sega product.
Old belt and suspenders, and that Ilbrook product is amazing. It's amazing how well it expands within its range.
Yeah, being the first one, you know, entertaining. I'll probably use the double one next time and just do it once. But like a belt and suspenders, you want to make sure the first one's is a good one.
All right, keeping along with questions.
It would be interesting as a test to do the expanding foam tape and then do a blower door and then put the interior tape on to see how much of a spread that does with the number.
Just to go back to questions, we had Kenneth Chan, you there?
Hey, how's it going, guys? Great project, Darryl. A couple questions. I think you might have answered this earlier, but your strapping is, you said you're going to use 1x for your strapping?
2x, Kenneth.
Okay, so are they 2x's on flats?
Yeah, they're 2x's on flats, and so the whole building is the exterior frame is 2x6 at 16 inches on center, and so we have 3 different cladding types. So we have real stone. That is not full bed, 5 inch. It's 1.25 inches, but it's real stone, and so it does have that weight. And so I'm going to be, for the stone areas on the home, on the cladding areas, I'm going to use the 2x4s at 16 inches on center vertically. There's also longboard, and those are fastened minimum 32 inches on center. So I'm going to put 2x4s every second stud on those. Then there's stucco. So the stucco is the majority of the project. It would be great if I could get every 2 foot on center, and then sheet it with 1/2 inch on the outside and the rain screen, and that would work. So I'm undecided if I'm going to put 16-inch centers on the whole outside of the building where the stucco is as well, or can I get away with every 32 inches on center? And so I'm still working with building envelope and structural engineer and our building official from the city to see those 3 advices, to be able to see if it's a good idea to go from 16 to 32 inches on center and then sheet it with 1/2 inch plywood. Will that be sufficient for it to carry the weight of the stucco and not have any future? So we haven't got there yet. So we have 3 cladding types. I figured out the first 2, rock and longboard, and then we're undecided still with the stucco, but all of it will be 2x4 on flat.
Right, and I was gonna say with stucco, from some of the buildings that I've worked on, having a backer board with your stucco would be really good to have that nice straight finish. But I'm more interested in hearing about your choice of your mineral wool, because you used 110 comfort board for the first 5 inches, I believe, of your exterior installation, and then what are you going to be using for your last 1 inch of your rigid mineral wool?
The outside will be only 5 inches of comfort board 110 rock wool. So
it's got like more compressive strength to it to take.
That's why, yes, I was very concerned with my clients. My client I've never built for. This client is looking at details and interior design details that I've had clients that have never done that before. So he notices the little imperfections, and so any building products that I can do to be able to improve the performance aesthetically, warranty, the perfect job, because the client says, you know what, I just want it correct. And a client that says, you know, it's not an open checkbook, but I want it done correctly. So let's make that the choice. And so 110 comfort board was that choice for the building because of that density, and it keeps the walls nice and flat.
Cool, good to know. Thanks so much.
And Ken, just to go over that detail again, you can see here these blocks that are in place. So they're a 2x6 with the compact foam, or sorry, this is just a rigid foam above here, and then you've got this 2x6 material here that'll catch all the top of the cladding, and then this board will also come down here, and even with the rock wool behind it, they're going to be able to have this very straight wall. I mean, this is a really skookum detail to ensure you've got a straight wall, because otherwise you got to really work hard on getting your strapping and using lasers or lines to ensure it's straight all the way up. This is a pretty skookum way of getting yourself started in the right direction.
This insulation behind the electrical panel is only 3 inches. It's not 5. It's a 400 amp service, so it's got a big panel. And so this is one of the walls that's going to get the stone veneer. And that's why you can see the towel and cable boxes beside it that haven't been mounted, because they're going to be mounted into the stone. But I didn't want the panel so far out of the building. Aesthetically, it's going to look really, really bad. And so we, as a compromise, just for the behind the panel, instead of 5, we put the 3. And we may introduce some more inside, just in that area in the inside of the building.
That's an amazing detail. It's very nice to see the thoughtfulness of putting insulation behind the panel. You don't see that often. I am really excited to see the final finished photos of this project. It's going to be amazing to see a back vented stucco system that has a very good chance of surviving the next 50 to 100 years, because that's how those cladding systems are supposed to dry. So it's very exciting.
I tell you what, Kevin, you're looking for the internal finishes. I'm looking for the thermal cam review showing us the difference between the longboard, the stucco, and the stone wall. Because there's no insulation on the interior, we're going to be able to see the true energy transfer of each of those studs and sheathing layer. That's brilliant. That's a work of art in and of itself to see those different options.
Yeah, this thing's pretty skookum. All right, guys, we got about 4 questions we're going to have to save for the overtime. But first, let's go to Mark, who's going to say a thank you.
I'm gonna follow the order here. Along the way, Kevin started this last week, and we were thanking our teachers. I'll get into thanks to Darryl in a second here because it's well deserved. Somewhere around 20 years ago, I was on Sacramento Avenue in Chicago. There's a gentleman by the name of Timothy Hepner. Some of you may have run across him over time, and I consider him a great colleague. He took a 100-year-old house that was moved once in the city of Chicago, and then he converted the multi-unit house into a single family house. And the teaching moment for me was at that time, finding green or energy efficient materials were hard, let alone books. And his he when he embarked on it, he wanted to use all local materials. So this was a little bit before LEED had their 500-mile radius bike rack program, and he brought these in. I see you laughing, Sean. He brought this in with all local materials. So at the time, you would remember the wall insulation of the denim jeans. You would remember the EPS foams, of course, the filter glass insulations, and the cellulose. Each wall was done with a different assembly. So my teacher at that stage was exploratory. And I think a lot of us remember our first projects being very exploratory. We didn't have these wicked awesome details of today. So that's my teacher moment. So thank you to the teachers out there. And each of you have had teachers. So we invite you to share them with the rest of us. And we invite you to teach others as well. So we postponed the attended guests for this week. And on Friday morning, I had a phone call with Sean, and he reached out to Darryl because they have been doing some videos along the way. It was thrilling to have you show these details, Darryl. I'm anxious to get into them in the after. What do we call it? The after party.
The overtime.
The overtime. So next week we have the guests coming. It is Matt Reisinger, Stephen Basic, and Jake Bruton, and they will be covering predominantly a thermally broken 18-foot by 10-foot offsite fabricated steel deck, as well as some other thermally broken insights. So that's next Tuesday. And I think we couldn't be here today without a great audience and without great teachers, and certainly without great sponsors. So I pass the torch to Zach in Seattle.
Thank you very much, Mark. Yes, it's true. Our work is impossible without the support of our sponsors. So I want to thank them. Our founding sponsors are 475 High Performance Building Supply, Baxtingui Architects, Mitsubishi Electric Train HVAC US, RDH Building Science, StoCorp, and Zola Windows. Our stakeholder partner is NYSERDA, and our patron sponsors are Innotech Windows and Doors, Morrison Hershfield, and Partel. Now, I want to share a couple of things that we have coming up. Tomorrow, we have our Global Passive House Happy Hour that will feature Neil Norris of Morrison Hershfield presenting about the Artscape Passive House building in Vancouver. And we just saw a run through of the presentation. It's a super cool project. I'll share information about how to access the happy hour for folks who haven't done that yet in chat in a moment. And then Mark just mentioned our exciting show next week with Matt Reisinger and the team there. So don't miss it next Tuesday. And coming up on Monday, December 14th, we have our Passive House Prefab Summit #2. Our first summit was so successful that we sold out. And so we've expanded our capacity on Zoom now, so that won't happen again. And we have new guests at this summit, a new format, and it should be really exciting. So I will share registration information in chat shortly. So thank you.
I just want to open up for 1 second and say we're a show of the people, and we want to give you guys what you want to see. So in the chat, hit up the topics that you want to see on the show, who you want to see, topics you want to be talking about. In the pre-show, we were talking about non-flammable facade panelization. Give us all your ideas, and then we'll try and do our best to deliver it. And without great people like Darryl and the craftsmanship that's out there, this show, we're just talking about our ideas. So let's make it happen.
All right, so that concludes the construction tech, and now we go to the overtime where we're going to answer the rest of the questions and just leave it unscripted. So we're very lucky. Just to give a little bit of backstory of, I've been involved with Darryl's project for a few months, but I was on last Thursday, like just how quickly this came together. Andrew Look from SEGA, who I believe is in the audience, him and I got invited to go look at the details that Darryl's working on with Hamid, who's the building envelope consultant. That's Hamid at his Hamid Design Build. Extraordinary gentleman that has, really pushed Darryl and his crew to just really focus on the details. And so, yeah, there's times where Darryl's torn apart stuff because Hamid didn't like it. And it pushed them to just, dial it in. And as you can see from the footage, it is, just amazing amount of work. So again, thanks Darryl for having us all along. It's a beautiful project.